A lot of problems with normal curves revolve around finding certain amounts of area underneath the normal curve. And one tool that we have to solve problems like this, or one of the oldest tools we have to solve problems like this, is something called a z-table or a normal curve table. So this deals with a standard normal curve, and what it will do is it will tell you sections of area between 0, which is the mean in this case, and some positive z-score. Let's try to make this a little bit bigger. So this is the way it'll work. It'll give you a piece of area like this between the mean and some positive z-score. So for example, or the example that is given to us on the z-table is they tell us, well, let's say we want to find the amount of area between 0 and let's set that z equal to 1.28. What we would need to do is find 1.28 on the table, and then this will tell us what the area is. So 1.2 is right over here. And then if we go over to 0.8, we put these together, we have 1.2, and then that makes 1.28, and then slide along here, and then slide down here, we get 0.3997. So that tells us we have about 39.97% of the data in that section between 0 and z is equal to 1.28. So now let's take a look at some examples of finding area this way. So let's say we want to find the percent of data between z is equal to 0 and z is equal to 1.62. So first we'll draw a picture representing what's going on here to visualize this. Oh, also one thing, if the problem doesn't give you any information about the type of normal distribution you're working with, if they say standard normal, if they say, z-table, if they say anything like that, just assume it's standard normal curve. Here they say nothing, so we're going to assume it's a standard normal curve. If they gave us any other information, we may have to do something different, and we'll look at that in future videos. So we're asked to find the percent of data between z is equal to 0 and z is equal to 1.26. Well, our mean is 0, so that's going to go directly in the middle of this standard normal table, and z is equal to 1.26. That's a positive number, so it's going to fall to the right of our mean. It's going to be somewhere here. And the area we want to find is this shaded region. Now this is where we're going to make use of our table. So we need to find 0.162 on the table, because the table will tell us the area between 0 and 1.62 as long as we can find this here. So first we would go to 1.6 over here. Then we want to go to 0.02 over here. And we're going to travel down, and we're going to go this way. By the way, all of you should be able to find a copy of this table on Google Classroom under one of the tabs under there. I think it's under classwork or something like that. But I did upload one of these so you all have access to it. So we go here, we find what we have here. So we get 0.4474. So the table's giving us this, and that tells us it's going to be 44.74%. Now we'll look at another question. Here they're asking us to find the percent of data between z is equal to negative 1.62 and z is equal to 0. So again, the first thing that we should do is draw a picture. Negative 1.62 is less than 0, so that number is going to fall to the left of the mean because it's less than it, and 0 is greater, and we know 0 is the mean, so that's going to fall directly in the middle of the curve. So the area we're looking for is this. Now, one problem that we think we might have here is that, well, this table just gives us amounts of area between 0 and some positive z-score. It's not giving us an amount of area between 0 and a negative z-score. But luckily, we have a fact that we can make use of to solve this. The fact that the normal curve is completely symmetrical around the mean is what we're going to use in order to solve it. So this problem that we just did is essentially the same thing as this. I know my graphs don't look exactly the same, but these are like mirror images of each other. The amount of area between 0 and positive 1.62 is going to be the same as the amount of area between 0 and negative 1.62. Okay, so again, we're going to end up with 44.74% here. Now the table only tells us how to find pieces of area like this, again, between 0 and some positive z-score. But, we've already seen another thing that they can ask us is to find the amount of area between a negative z-score and 0. There's a bunch of other types of area that they can ask us to find, and all of the different types of area they can ask us to find are here. Let's see. Okay, so this is what we've just seen. And then in the next video, we're going to talk about the differences between all of these other types of ways. So they could ask us to find between a negative and a positive z-score. They could ask us to find the amount of area to the left of a score or to the right of some z-score. They could ask us to find the amount of area between two positive z-scores or between two negative z-scores. And then again, they could also ask us to find, the area to the right of a z-score or to the left of a z-score like this. And these are all going to require different techniques. Obviously, this is the easiest one right now. So next video, we'll talk about what to do with these. We can also talk about how to solve this type of problem on the calculator. If you have a TI-83 Plus, you can do pretty much all these problems on the calculator without any issue. These directions are going to be very similar for the TI-84, but I know the TI-84 is a little bit more user-friendly. Let's say we wanted to, go do this example again. Find the percent of data between z is equal to 0 and z is equal to 1.62. What we would do on the calculator for this is first hit the second button, then hit the vars button. So we want to hit our second button first. First we want to turn it on. We want to hit our, wrong thing. We want to hit our second button first. Then we want to hit this button over here that says vars. You see how it says DISTR on top of it? That means we're going into something called distributions, and the normal distribution is one of them, so that's what we want to do. Now we want to hit 2, which is normal CDF. The second thing that comes up here is normal CDF. Okay, don't stay away from normal PDF. We're not using that here. Make sure that you use normal CDF. Then we would hit enter over there, and now we're going to see normal CDF on our screen like this. Now what you have to input in here is your lower limit, or this is your smaller z-score, your upper limit, which is your bigger score, the mean of the normal distribution you're working with, and the standard deviation of the normal distribution you're working with. Okay. And in this example, we are going to be putting in a smaller z-score and larger z-score, but in other problems, they may not necessarily be z-scores. And just again to review, this is our mean, and that's your standard deviation. For standard normal, this is going to be 0, and that's always going to be 1. In more advanced problems, you're maybe given different means, different standard deviations, and then you would put in whatever numbers you're given instead of 0 and 1. So we'll go back here, and we'll see what we had. Okay, so we had a z-score of 0 and a z-score of 1.62. So what we would put in our calculator over here is normal CDF. Our lower score is 0, our higher or lower limit is 0, our upper limit is 1.62. So we'd put in 0, a comma, 1.62, comma, because this is standard normal, our mean is 0, and our standard deviation is 1. So we would put this in, hit enter, and see what we get. 0, and then also make sure you know where the comma button is, or you will have problems. Okay, yeah, comma button's here. We want to have it in like this, then we want to hit enter, and we end up with 0.4473 and, more stuff after that. So this is going to round to what we have over here. This is more precise because the table is limited. They had to round numbers off. This is a more precise answer, but this is still all right. So we have 0.447, what do we have, 3, and then we can round we could round the 3 up to 4 because there's an 8 after it, or 44.74%. If we were to look at the not backwards problem, if we were to look at the other piece of area in this problem, again, we would end up with the same thing, except we could put different numbers into the calculator when solving this. So we would go back through all those steps again, go to normal CDF. Now our lower number is negative 1.62. Our higher number in this case is 0. Our mean is 0, and our standard deviation is 1. And now if we put this in, we should end up with the exact same thing. And we will end up with the same thing if we put that in. So if we go from negative 1.62 to 0, input this in the calculator correctly, we end up with the exact same answer that we had for the other one. And again, this is because the normal curve is totally symmetrical.